everyone, this is Kalpana here. In this video we are going to see a problem from partial differential equations. So we are going to see only one problem in this video. Let's get going. Problem: solve dou square z by dou x dou y equal to x square plus y square. We'll do a rough work first, okay? Dou square z by dou x dou y equal to x square plus y square is a given equation. We can write this as dou by dou x of dou z dou y equal to x square plus y square. Okay, now I'll see the first thing, dou by dou x, right? So I'll take this dou x to RHS, or I'll multiply both sides of the equation with dou x. Since we are having dou x, we'll just integrate with respect to, integrating partially with respect to x, treating y as constant. Here y square is treated as constant. This dou and this integral gets cancelled and you'll get dou z by dou y equal to x cube by 3 plus y square, constant into integral dou x is x plus some function, we'll get a const of integration, right? Here we treated y as constant, right? So we'll get a const of integration which is in terms of y, not in terms of y. We can say it a function of y, say f of y. Okay, again you write the same thing as, just take this dou y to RHS. You'll distribute dou y to these three terms. Now integrate it. We'll get z equal to x cube by 3 into integral dou y plus x is treated as constant since we are integrating with respect to y. Okay, so you'll get y square dou y, right? You'll get dou cube by 3 plus, assume integral f of y. You can write, see here you have everything in terms of y, so instead of writing dou y you can write dy here. You can write this as, you can assume it as f of y. You'll get f of y plus some integral constant. Here we are integrating with respect to y, treating x as constant, so you'll get const of integration in terms of function of x, let it be g of x, phi of x, or whatever. I'll take phi of x. So this will be the solution to the problem. This is a rough work. Okay, now I'll show it properly. Given dou square z by dou x dou y equal to x square plus y square, consider as equation number 1. Now we can write this as dou by dou x of dou z by dou y equal to x square plus y square. Here we notice that we are having dou x in the denominator, so we'll integrate it with respect to x, treating y as constant. So integrating partially with respect to x, treating y as constant, then this becomes dou z by dou y. You'll just do directly, okay? There I wrote a integration symbol, but actually in many textbooks they are doing directly without using the integration symbol. Okay, this is equal to integral x square with respect to x is x cube by 3 plus y square is treated as constant, so integral y square with respect to x is y square into x plus, here we are treating y as constant, so we'll get a const of integration which is a function of y, say f of y. I'll write f of y. Again here you're having dou z by dou y, so we'll integrate partially with respect to y. Okay, this gives us, okay, let me write the sentence. Integrating partially with respect to x, treating y as constant. here I'll get one more constant of integration with respect to, here we have to do with respect to y, right? Treating x as constant, sorry. So we'll get constant of integration, which is a function of x, say phi of x, constant of integration, which is constant of integration, okay? And this becomes z equal to integral x cubed by 3 with respect to y is x cubed by 3 into y plus, treat this x as constant, we'll get x into integral y square with respect to y is 2, okay, it's integration, right? You'll get y cubed by 3 plus integral f of y with respect to y. Everything is in terms of y. So we'll write just integral f of y. Instead of writing dou y, we'll write dy because everything in terms of y, right? You can consider it as ODE. There is no partial in necessary to this step. I mean to this term because everything is in terms of y. So instead of writing dou y, you can write dy. There is nothing change in it, right? If you have another variable x or something, then you write dou y or whatever. But here only in terms of y, f of y, dou y. So you can write dy instead of writing dou y plus constant of integration f of x. Now assume or let integral f of y dy equal to capital F of y. Okay, then this becomes z equal to x cube y by 3 plus xy cube by 3 plus integral f of y dy is capital F of y plus phi of x, where f of y and phi of y are, where f of y and phi of x are arbitrary constants, functions, right? Where f of y and phi of x are arbitrary functions. Okay, this completes the problem. This is the required solution, you can see. Also, you can write the same equation as, you can take xy by 3 common from these two terms or xy common from these two terms. Suppose if you take xy common from these two terms, then this becomes z equal to xy into, here you'll get 2x, right? I mean x square plus here 2x, 2y, y square by 3 plus f of y plus phi of x will be the solution. See, xy into x square gives x cube y, xy cube, I mean xy into y square gives xy cube. We'll get the same thing, right? Fine. Well, we have seen a problem from partial differential equations in this video. I hope you'll understand. We'll see you in the next video. Until then, bye bye.